Hello and welcome to this presentation of Maidenhead Bridge about private cloud, private access, cloud security connectors. About Maidenhead Bridge. Motivated by the Unix-inspired mantra of do one thing and do it well, Maidenhead Bridge is an independent software vendor in the emerging category of multi-cloud network software providers, MCNS, and enables customers to connect to Secure Service Edge SSE clouds with its cloud security connectors. Maidenhead Bridge was founded in 2016 in England and helps customers to connect to Zscaler Cloud and Netscope Cloud, both Gartner leaders. More recently, the company created an innovative technology called Private Cloud Private Access, PriCPA, that simplifies and secures cloud-to-cloud, site-to-cloud, and site-to-site networking. Maidenhead Bridge has more than 250 customers worldwide. Maidenhead Bridge was founded by Adrian Larson, a member of the first AC team of Zscaler in 2009, and was created to solve the challenge when connecting to SEC vendors from public clouds, AWS, Azure, G-Cloud, and on-prem. This presentation will be focused on the product Private Cloud Private Access. And Private Cloud Private Access is a cloud native solution for WAN communications that covers the scenario of site-to-site, site-to-cloud, and cloud-to-cloud, following the principles of Zero Trust. Legacy security networking solutions cannot be forklifted to the cloud. There are technical, operational, and security limitations when using legacy solutions. Networking engineers designed legacy networking solutions to communicate branches, central offices, and data centers. Cloud communications arrived with new challenge of networking, security, and mainly operational agility. Applications are now distributed in multiple VNETs, VPCs of different clouds. APIs are required to be accessed from numerous sites. And we still need to communicate with on-prem services. An agile method of any-to-any, secure encrypted communication with zero trust is required. And PriCPA, Private Cloud Private Access, is the answer to this challenge. Let's now take a review of what are the status of WAN communications. Currently, we have MPLS networks, and MPLS has its benefits and drawbacks. And let's take a look about it. MPLS has as a benefit that enables any-to-any communication via labeling switching. It supports traffic engineering. It's okay. This internet is good for transport, and all port and protocols are supported. The drawbacks of MPLS is the traffic is encrypted, it's very expensive, it's a bottleneck to the internet in this kind of going out for a single point, and it's not zero trust at all. Then it's not encrypting and it's not zero trust. That are the objectives we want to achieve. And also to provide something cheap, right? Not so expensive like MPLS. Then the solution to MPLS was SD-WAN. And the benefit of SD-WAN, SD-WAN as a benefit use internet as transport and has the ability to do site-to-site communications. Then the main benefit is cheap internet link as transport, the traffic is encrypted, and all protocols are supported. The drawbacks of SD-WAN, the number one, they communicate using IPsec tunnels to each other. Then if you have 10 sites and you want to do an any-to-any communication, you will need to do 99 tunnels. Then SD-WAN is not scalable for any-to-any communications. It is okay when you need to go to a data center and the internet, or the split in 2 and 3, but it's not scalable for any-to-any communications. SD-WAN devices in general are very outdated with unmaintained Linux kernels, and this is a security risk. Most of them were created in 2000, before 2010, and if you check, they will use CentOS, that is end of life, and with kernels 3.5 or something like that. From the security point of view, it's unacceptable, this type of Linux kernel on a security device. Then check your vendor before to decide to go with an SD-WAN. It's not if you are worried about security. If you don't care about security, go ahead. It's not cloud friendly. These devices were created for the replacement of MPLS, not to communicate to cloud. And it's not zero trust at all. Then one communication, this device in this subnet can see all devices in the other subnet. There is no restriction. The next evolution on private traffic is how to communicate your data center with the clouds. And the clouds are offering you several tools, express routing, direct links, some WAN communications, and mostly what most common people is using VPN gateways. All of them have the same problem we are going to talk here. And then let's talk about the benefit first of this communication. Is encrypted traffic because they are using IPsec and all protocols are supported. That is good. Let's talk about the problems here. Very expensive solution. The VPN gateways are not cheap. The lack of scalability. Remember, our objective is any-to-any communications with encrypted with zero trust. If you want to do any-to-any communications here and you have 10 sites, you will need to create 99 tunnels. This is not zero trust. This machine here will, via the IPsec tunnel, will have visibility of all machines on this subnet. We don't want that. We want this machine going, allowing only to access a specific port and protocol application on this instance. There is no zero trust. And finally, this is very complex to set up, if not impossible, to do any-to-any communications. And you need to have a BGP for routing as a routing protocol because this setup has no intelligence, routing intelligence by itself. You need to add BGP, and it's not always possible to add BGP, or you don't have the knowledge, or you don't want to do this complex setup. Then the drawbacks are several. To solve this problem is a new solution that is offered by several companies, that is secure cloud brokers. What is secure cloud broker? A secure cloud broker is a man in the middle here, another cloud. Then if you want to connect Azure to the AWS, you need to pass through another cloud. And the way that it works is they tell you to put a connector in each place. And this connector will connect to a node, to the instance in the cloud. And from the cloud here, the broker will enable the communication from this machine to this instance in a particular port and protocol. Then the main benefit of this solution is zero trust, yes, and scalability. As you can see, the full mesh or the problem with the tunnels is gone. But there are several drawbacks on this secure broker cloud. First, it's very expensive. Of course, it's a man in the middle, and this cloud need to have nodes to attend your connectors, to run, they consume traffic. Then you will pay for all the computing and networking use in the service broker cloud. At the end, the solution is very expensive. In general, they don't support all port and protocols. If you want to do a ping, maybe to this instance, it's not possible. Surprise, surprise. In general, they are very good. They can do UDP, TCP, but Some voice protocols who are not supported, AlgoSec. Well, there are several limitations on the service broker cloud. We support it, then you need to check this before to implement it. The data in transit is not encrypted. Again, the three objectives we want is any-to-any communications, encrypted, and zero trust. The service broker cloud doesn't provide encryption inside the cloud by default. You will have encrypted from the connector internet to the cloud, but inside the cloud, if you do a telnet from this machine to this instance, this telnet will pass in clear, and the secure broker cloud will have visibility of all your traffic. If you want to have this encrypted, yes, you can. They offer you the option to pay more, and they will encrypt the telnet. But it's an extra license. You need to pay more. By default, they are not encrypted. Poor performance. In general, the connector, this connector is running in user space, is a Linux box. Some of them running outdated kernels. Check the kernel. If you want to do encryption, full encryption, the communication drops to the half. According to our experience, I never saw one of the solutions going more than 500 meg, and as soon you enable full encryption, the capacity drops to a half, 250 megs. Then very poor performance they offer. And finally, in terms of visibility, all traffic here is NAT at all points. Then when this machine goes to this instance, this connector will NAT, and the source IP that this application will see is the connector IP and not this PC IP. Then there is no good visibility end-to-end here. Of course, the service broker cloud should provide you a log that say the source IP was connecting to this destination IP. But your application here will never, ever have the right logs on it. You will have all coming from a single IP from the connector. Then this solution is quite problematic in terms of performance, in terms of encryption, in terms of visibility. And this is our solution. In our solution, each node works like the broker in very similar way that the service broker cloud, but the difference is the same node is managing, let's cut in half the node here, and half of the node is attending the service of the cloud, like a broker, and half of the node is attending the edge and the connectivity and the zero trust. The main advantage here is we allow any-to-any communications, all traffic is encrypted, and it's zero trust. And there is no man in the middle. The cloud is in your device. Then this is pure internet communication with no cloud in the middle, no man in the middle. Removing the man in the middle arrives with the number one benefit is 80% on savings when comparing with VPN gateways or service broker clouds. Then the first impact in your communication is a big savings because there is no man in the middle. That's it. In terms of technology, well, any-to-any communications, we use crypto key routing. This is a new technology, and each packet has its own encryption, and you don't need to have a tunnel in advance. Then the problem of if you have 10 site, 98 tunnel is gone. This is packet per packet encryption. All traffic is encrypted, of course. All protocols are supported, of course. It's very scalable. You can put multiple sites, or you can create clouds, several. You can say, okay, I want to create a cloud for that particular department. I want to create a private cloud communications for my backend or something very specific that you want to isolate from the others, or you can create private cloud for your providers. Then you can say your provider install this virtual machine and you will communicate to me via this environment that is very controlled environment uh, by you. Then a provider, one of the problems is if you do an IPsec link, most likely your provider will be able to scan all your network. In this case, will not be possible at all. Then you can connect to your providers in very security way, creating more than one PriCPA cloud. It is zero trust, 100%. In this machine, will be able to communicate with this instance in a port and protocol you want, but it will not be able to read or to have visibility of any other machine inside this AWS environment. The lateral movement is blocked completely. This machine has visibility to this and nothing else. On IPsec, this machine will be able to scan everything in the other end. This is not the case here, it's zero trust. Is networking as a code? Yes, it's DevOps-oriented. The configuration, we will see in the next slide how is the configuration, but the idea is something new. No, the command line, all the old stuff, all school is gone. The new world is DevOps, create a perfect template, that the connector is a perfect template and manage from a single JSON file. The configuration is two-step. I will show you in a minute how you need to onboard first the node to the cloud, this your private cloud, and the second you need to deploy the policies. You want to say, okay, I want this machine to connect to this instance. The traffic visibility is end-to-end. There is not NAT in the middle. Then if this machine accesses this instance or this application will have all the logs on it, the source IP of the device who accessed it, and what this device was doing. Traffic logs, yes, the cloud provides traffic logs. You will be able to see all logs or traffic block allowed logs. Blocks lateral movement because it's a zero trust. It's high performance. Every site is 1 gig. There is no limit if there is many places or many devices. Remember, we don't have tunnels in advance. Then the scalability here is related to how much traffic is arriving to the node. And each node is capable of 1 gig. The architecture, going technical here, is very simple to set up. When you're using your cloud environment, on Azure or AWS or G-Cloud. G-Cloud will be available soon. The setup is extremely simple. On the cloud, when you launch the connector using Terraform or using Resource Manager or using CloudFormation, the connector will create most of the configuration automatically, reading the public IPs, all the stuff. Then you need to do a little setup, and the setup is to select a subnet for your private cloud. This is for the cloud, for the connectors. In my case, I selected this 192.168.7, okay, and 1, 2, 3, and 4. Of course, you need to know the public IP and select the port for the node. And finally, the next information you need to have in hand is the subnets behind each node. And that's it. You're not going to configure any tunnel here. You're not going to configure any routing here. With this information, the subnet for the cloud, the public IPs, and the subnets behind, you are ready to go to deploy your private cloud. And how is the configuration? It's two-step configuration. You need to do a local setup in the node. You are going to create your public key for encryption. This public key will be shared with the other nodes. And here the information we show, it was shown in the previous slide, public IP and private IP of the node. That's much it. When there is information, local information, you need to create your peers JSON file. Okay, this is the key here. Then you add the node to the peers JSON file. On the top, you need to put your basic configuration, but here will be the public key of the node and the information, public and private IPs of the node. Your next step on the peer JSON file is to say the networks behind the node. Then this is my 3 subnets behind the node. And finally, you need to define the private apps behind this node. In this particular case, I have this rule that says I will allow description SSH and RDP from my management networks. My protocol is TCP. The source IP, these are my management networks, will be my management networks. The destination is this server that I want to access. And the ports are 22 and 338. And that's it. You need to distribute the peer.json file to all nodes in the cloud, and each node will understand how to create the rules for zero trust to allow this communication from this origin to this destination TCP port and protocol. If you check here, we did something very interesting, because in security in general, the people configure that says, okay, this is my user and where the user need to go. And this is quite confusing because you don't know. You don't have complete visibility of what the user need to go. But in this configuration, we are reversing this logic and saying we know this application and the application port and destinations. Instead to open to entire users, we know that the application need to be accessed by these specific origins. Then it's much simple to know and to configure from the point of view of the application who needs to access to the application, the owner of the application know it, than from the user point of view where the user need to go. Then this configuration will simplify your network and rules. As you can see, this is a networking effect code, and let me show you for a minute a complete JSON file, the peer JSON file. This is a JSON file where I have multiple nodes on my PriCPA cloud. I have this node. This is the standard local configuration. This is the backup IPs because this node is on a VMware, and this node has 4 links to the internet. Then if the exit link change, the node is smart to use any of the source IPs available. This is the networks behind this node. It's only one subnet. In this case, I'm allowing all traffic to this subnet. This is node on AWS. It's in Virginia. It has this 2 subnets behind, and also enable this node. I have a node in Japan. This network, but in all cases, you need to define where this is more complex. This is the another node on AWS. I have several nodes here. I'm trying to reach a domain controller. In G-Cloud, more than AWS. Here I have. For example, this is a domain controller rule. As you can see, it's very simple. You need to create 2 rules for the domain controller, and this is the recommended by Microsoft. Then you have a TCP rule to create with all this to the domain controller destination. All these ports need to be open, and all these dynamic or these high ports as well. And in terms of UDP, the recommended port and protocols for a domain controller are these few. Then, as you can see, you can create a zero trust communication for your domain controller, and it will not be nobody on the subnet on your entire network will be able to access to anything different than the ports that are recommended to have opened. This cloud is a worldwide cloud. I have several connectors. I have 13 in United States, 8 in Europe, Japan, Australia, and South America. As you can see, the only task you will need to maintain is this JSON file. I recommend to use Virtual Studio Code, but it's extremely simple to do the rules. And you distribute, and the nodes will create all policies, and you don't need to do any rule manually. Going back to our presentation, let me put this bigger. Okay. Now let's show the products we have available. We have available the PriCPA on AWS, and the deployment is extremely simple. You can deploy a single instance or on high availability. If nothing else is needed, you don't need to have a load balancer or a NAT gateway. No, it's only the only requirement to install the connector on AWS is to have in your VPC a public subnet available and a private subnet available. The connector is like a firewall and will isolate the traffic in, out, internal traffic to external traffic. The connector is smart enough to update the security groups here if you add more nodes on your private cloud. As soon as you distribute the JSON file to all of them, this one will create automatically the security groups to enable new nodes to connect to. And you don't need to do any job here. If you want to deploy in high availability, as recommended by AWS, you need to use two zones, availability zone 1 and 2, for example, and the connector has the intelligence here to manipulate the target of the routes via the ENI of each connector, the one that is active, and also to move the public IP of the connector from the active one. Then again, in high availability, you don't need nothing else. The connector will manage the internal routing and will select the ENI of the active connector. Similar to AWS, on Azure, the setup is the same. The connector is capable to manage all security groups. If you add nodes, it will manage the route table behind the connector to select the connector active to go via the right place if you put on high availability. When you are on-prem, then the connector will be in your VMware Hyper-V or KVM. Then you need to install, we will provide you a virtual machine with the IP. You need to fill a form with the IP, gateway, blah, 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 and to download the machine with the configuration ready. Then your task will be to deploy on your VMware Hyper-V or KVM and to do this two-step configuration, local configuration and the peers JSON file for this on-prem place. In this particular case, in your firewall, we provide a JSON file with the firewall rules that we need to have available. In this case, we are not automatically creating the firewall rules like in the cloud. In this case, you will need to implement the rules in your firewall, but we will provide, the connector provides you the configuration with all the rules that are required. In terms of management, monitoring, and tools, we have several tools available for deployment. You can use CloudFormation, Terraform, or Microsoft Resource Manager. If you want to do a monitoring of the connector and to do change management and to deploy the JSON file, you can use System Manager, you can use Rundeck, you can use Ansible, you can use Azure Arc, you can use any tool that you are using for change management. Of course, we recommend to use AWS System Manager, that is quite handy. It's free, that is good, and incredible stable and the agent, very mature agent. Then for sure, my favorite tool to do monitoring and change management is to use AWS System Manager. Internally, the connector provides TCP dump if you want to analyze some particular packet or communication. If you need the access to the connector can be with multi-factor authentication if you want to. And in terms of getting statistics and bandwidth and all the stuff, you can use SNP and you will get all the information from SNP, the statistic, traffic, CPU, memory, and on each interface. And inside the SSH console of the connector, there is also a bandwidth monitor that you can see traffic in real time. But SNMP also provides traffic on real time in this case. And finally, we are security people. We want logs. Then the connector will be able to set logs to use SIEM or log collector or Azure Sentinel, and you will be able to see if the traffic is allowed or blocked, and you will be able to analyze uh, all your traffic, all the logs on the SIEM tool. Well, this is the end of the presentation. My name is Adrian Larsen. Here is my email. Please feel free to contact me, but also you can contact our team via sales@maydehbridge.com or visiting our website. And in case you need support, please go to http://support.maydehbridge.com. Thank you very much for your time. I hope you enjoy this presentation and see you soon.